हेलो। माइक टेस्टिंग, माइक टेस्टिंग। Yes. Yeah. Good evening. Uh, in continuation to the yesterday's lesson, it is separation and extraction. Yesterday we have completed the definition and some theories regarding the separation and extraction, and one of the problem also we have solved. Now, in continuation to the topic, the factors which are affecting on solvent extraction. The topic is factors. Just a minute. Yeah. Factors affecting on solvent extraction. Then what are the factors? We have so many factors are there which are affecting an effective solvent extraction. Some of them are first one, choice of solvent. Choice of solvent. Then how this choice of solvent is effective. Now, we have so many solvents are available. That is the variety kind of solvents are available for the extraction of solute present in a solution. But here we can categorize it to two types of solvents when we compare to the water. Here the water is the reference. Based on the water density, we can classify these solvents in two types. The first one is when we compare the density heavier than the water. Its density is heavier than the water. The solvent type is heavier than the water. For example, we have so many solvents are there. Some of them are chloro chloroform, carbon tetrachloride, and carbon disulfide. Some of them are the example for the solvents which are heavier than the water. And the second type is lighter than the water. These are the solvent type 1 and solvent type 2. Example for the lighter. We have so many examples are there from which I have considered some of them are you choose diethyl ether and benzene, benzene, hexane, toluene, butanol, it. These are the example for the solvents which are lighter than the water. Now, the size of solvents for extraction is can be considered can be considered uh, by using the following factors. By using the following factor, that kind of whatever the solvents which are we are going to be used in this solvent extraction of a solute present in a solution, that should be have some characteristics such as a higher distribution coefficient, higher distribution coefficient, that is expressed in the Kd. For the solute, with respect to solute, whatever the solvent used for the extract, that should have higher Kd value, that is the distribution coefficient value for the solvent, and the same for the solute. Just a minute. For the solute, that to be extract, extract, and similarly, and lower distribution constant or distribution coefficient, that is the Kd, for the unwanted or undesired compounds. For the unwanted or undesired, undesired impurities or compounds. Or compounds. Okay, this is the first important fact, because whenever we are selecting the solvent, that should be in such a way that should dissolve the solute more, and it should not dissolve the unwanted or undesired products. That is depends on the distribution coefficient. If it is having the higher distribution coefficient towards the solute, then it can dissolve more amount of solute in it. Therefore, the solvent should be higher distribution coefficient per solute, which we are going to be extracted from the solution, and lower distribution coefficient for the unwanted or undesired impurities or compounds present in the solution. Next, second factor, which is highly influenced by the solvent nature, that is high selectivity. High selectivity. How this selectivity? What is the selectivity? The selectivity means the solvent should have the nature can dissolve the whatever the compound we are going to, or whatever the solute which are going to be extract. That means it should high solubility for the solute to be extract. That is the high selectivity. Next, third one, immiscible and we are very less solubility. But my priority, not only my priority, any chemist priority is the extracting solvent should not be dissolved in the solution of the solute. That means the solute is dissolved some other solvent, it is present in the solution. Whenever we are going to extract, we are need to add other solvent. That solvent should not dissolve at any cost. It should not dissolve. And in some cases, it may be permissible to partially soluble, or a lower amount of solvent should can able to soluble. That is permissible, but not all the cases. But always the chemist priority is that should not be dissolved, that should not be miscible. Therefore, solvent should be immiscible, immiscible, or very, you can call it very low solubility, solubility for the solubility with the solution of solute. Okay, this is the third factor. Next, fourth one, low toxicity, low toxic in nature. That means we are working with a bulk amount of toxicity. We are working with a bulk amount of solvent when we are doing the extraction. Therefore, that should be low toxicity, that is less poisonous nature and less danger to the human health. That should be care we need to take when we are doing the extraction. Therefore, the solvent should be less toxic. Suppose if you are using benzene, it's somewhat toxic and highly carcinogenic nature because its planar nature of structure, it can absorbed some if any some part of or some amount of benzene is absorbed into the body that may slips into the genetic material, then it alters the structure of the genetic material. Therefore, it causes the cancer. Okay, we have some such studies are also there. Therefore, whatever the solvent which are we are going to be used in the extraction, that should be low toxicity or intoxic in nature, not intoxic in nature, right? Next, low flammability. Here again, this is also important factor. Low inflammatory, inflammability. Inflammability. That means it should not catch fire. It must to be temperature resistant. It should not catch easily the fire because we are working with so many organic solvent. Most of them are highly flammable. Due to that reason, while you are working with those solvents, you should take maximum care. Maximum care. Therefore, here, whenever we are going to select the solvent, we have the more choices are there from which we need to select low inflammability solvent should need to select. Okay. Then other one, blast resistant. Why blast resistant is a special case here? Blast resistance, while you are working with extractions, we are preserved in the all the extraction at some tanks or some vessels or some round bottom glass or some other cans. Suppose it is highly volatile in nature, highly volatile in nature, it creates the pressure. So if the whatever the vessel is which we are going to preserve in it, that should not bear the higher pressures, it may causes the explosions or blast. Therefore, while you are selecting the solvent, that should not be okay, should not have the nature to blast or undergoing the explosions. Okay. Next, next one. Low viscosity. The low viscosity is the physical phenomena. This should also be taken care while you are selecting the solvent. Viscosity. Next. Next one. F. Right. What is the F? Sufficient density difference from the aqueous phase or in order to avoid the formation of emulsion. Suppose the extraction involving the water and some other organic solvent. While you are doing the extraction, if they should have suitable density, that means water is having the density almost 1 gram per 1 ml. Right. Whenever we are taking the organic solvent, it should not equal to the water density. If it is equal to the water density, it is having the problem. It forms a emulsion. For that emulsion solution, we are unable to separate them. Okay. Once the solvents are not separable, we cannot separate the solute. That is the reason they should maintain the suitable density difference, density difference from the aqueous phase in order to avoid the formation of emulsion. Avoid to formation of emulsion. The separation of emulsions is very difficult, right? Therefore, that should not be comparable densities of the solvents that should not use it in the extraction. Next point. Chemical inactivity, because if we are using two solvents in extraction, if they are undergoing any chemical reaction, there is no meaning, because once they are undergoing chemical reaction, both the solvents can generate the new product, one of the other compound. Therefore it causes the adding the another compound to the solute. Therefore it increases the quality of the solute after extraction or before extraction. Okay, when we compare them, therefore the solvent should not be chemically reactive, and oxidizing is ability also should be low. Once they are in contact with atmosphere, they are undergoing atmospheric oxidation. Okay, therefore, while you are selecting the solvents, the nature of oxidizing at atmosphere should be low. Okay, therefore, the next G point G is chemically inactive, chemically inactive and low oxidizing ability, right? Next, cheaply available. It is a very important phenomenon, because while you are doing when we are doing the separation in the R&D lab, we are using a little amount of solvents, little amount or little quantity of solvent. Therefore, we can bear in the R&D. But the same procedure we are extended to our scale up to the production scale. It is very difficult, because if you are using the costly solvents in the separation or extraction, the same solvent should not be utilized in the production, because it increases the production cost. Therefore, while you are identifying the solvents for extraction, that solvent should be cheap in nature. Cheap, that means low expensive. Cheaply available. Cheaply available. Next, last one, the solvent should be easily recovered. Easily recovered. And the solvent should be easily removed from the extracted solute. Suppose after extraction, if you are unable to remove the solvent, we cannot get the solute. That is the reason we need to remove the solvent, but the removal is difficult. The extraction is also difficult. By which, while you are doing the extraction process, you need to select the solvent should be easily removable. That means, suppose if the solvent is highly volatile, you can boil it, you can distill it, we'll get the we'll get the solvent separated from the extracted mass, then extracted mixture, then we can get the solute separate and the solvent separate. Okay, if it is higher boiling point, we need to apply the higher energy, higher heats. At the higher heats or higher temperatures, the whatever the solute present in the solution mixture after extraction, it may not be as stable. Therefore, whenever we are heating to higher temperature, that is undergoing dissociation or association or degradation. Okay, we need to avoid the difficulty. We need to avoid the difficulty while you are selecting the solvent. Why? Again, I'm repeating, the solvent selection is very important. Solvent selection is very important. The solvent should be two types. One is the higher density than the water, lower density than the water. Based on the compound nature, we need to select the solvent. And after selection of the solvent, the solvent should be the higher distribution coefficient for the solute for extraction, and lower distribution coefficient for the unwanted or undesired impurities or compounds present in this mixture. And high selectivity means that based on the solubility, that is the if it is highly soluble, that is the highly selective solvent. Therefore, that should be highly selective, and immiscible or very soluble with the solution of solute. That means immiscibility is important phenomena. Highly immiscible is preferable. Low toxicity, that should not be a toxic in nature, and low inflammability. That means it should not catch fire, or it is not undergo any blasts or explosions. And low viscosity, suitable density difference should be maintained for the separation of solute from the solvent extraction. If it is the water and other organic solvents are having the comparable densities, they form the emulsions. Once the forms the emulsion, that is difficult to separation. Next one is the chemically inactive and low oxidizing ability. They should not be react with each other. Then only we can separate the solute from it. Therefore, the solvent which are used in the extraction should not be reactive and should not be undergo any chemical association dissociation reactions. And at the same time, oxidation reaction also need to be need to be considered while you are selecting the solvent for extraction. Then while you are doing the extraction, another important factor is to select the solvent that should be cheaply available and more abundantly available in the market. Well, then only we can decrease the production cost, right? Next, easily recoverable. All these factors are very important while you are selecting the solvents. Next, next phenomena is which is affecting on the extraction is pH. Right. pH is the important factor. We already know that pH plays the important role while its solubility in the solvents. Okay, pH value or also called as the hydrogen concentration of the system. This concentration plays important role in the solution or solvent systems. Okay, that is also influences the extraction process. It is observed that in pharmaceutical field, most of the drugs and other substances are either weak acids or weak bases or their salts. Okay, depending upon their pH, these solutions pH of these solutions, the drug may be exist in the form of ionized, that means in the charged, or the charged maybe forms the salts. Okay, the salt in the nature or ionic in nature, there may be positive charged or negatively charged ion, or sometimes unionized, that is the non-polar form or in the neutral form. Therefore, solubility of the drug depends on their ionization state. The neutral forms are more soluble in non-polar solvents. Suppose if we consider the neutral compound, there is no polar groups in that molecule. Therefore, it is preferably soluble in the non-polar solvents. For example, diethyl, ether, chloroform, benzene. This can be easily solvates the non-polar compounds. Similarly, the ionized forms of soluble Ionized forms are soluble in polar solvents like alcohol, water, acetone. Like the drug molecule which are polar, polar means a partially charged or a fully charged, like positive or negative partial charges may be generated due to the higher dipole moments. Sometimes, due to the polarity of bonds, it can generate the partial charges on the molecule, and sometimes they can be ionizable in the solvent system. Therefore, they can produce the ions. In such case, they can be easily soluble in the alcohols and water. Thus, by adjusting the pH of the solution, we can convert the solute into ionized or unionized forms and gets extracted it in a suitable solvent. Okay, this is the one factor. Next, modifier. This is the modifiers are the external substances. These are the external substance. These substances are generally added to the after solute is dissolved in this one of the solvent, a solution is generated from which we are going to separate the solute by using the another solvent. Okay, but the separation or extraction is not effective. In such case, we need to add some other external substance. Where once we are adding the external substance, the extraction velocity or extraction efficiency becomes increases. How this is increased? These modifiers are the substances are added to the organic phases to increase the solubility of solute in organic phase. For example, we have using higher molecular weight alcohols like camphor, alcohol, camphor alcohols. These camphor alcohols increases the polarity. Once the polarity increases, that solubility becomes increases. Okay, then the solute which is present in the aqueous medium easily transferred to the organic solvents. Okay, this is the these are the modifiers. These modifiers are the external substances. These external substances can improve the extraction speed or extraction process or extraction efficiency. Next, salting out, or this is also called salt effect. Salting out, salting out. This is also called in the industry CD. Okay, salt CD, salt CD, salt CD. What's happening in the salt seeding or salting out? It is the whenever we are using to add a salt to the solution, the reduction of the solubility of non-electrolyte by increasing the ionic strength is called salting out effect. Salting out effect. Suppose in the extraction procedure, compound is present in organic solvent. When we are going to extract with some aqueous reagent. Therefore, if we are adding some salt, if we are adding some salt, then that increases the ionic strength. Okay. Therefore, the reduction of the solubility of non-electrolyte in the organic molecule is there any non-electrolyte is there? Is non-electrolyte is there? That is the impurity or the non-desired compound that is present in the organic solvent, and desired compound is the already salt in nature or polar in nature. Therefore, whenever we are adding the salt, that increases the ionic strength. Therefore, whatever the polar or salt compound is, there immediately soluble, more concentration of the solute is transferred to the aqueous medium. Or if we are taking the reverse, the mixture is present in the aqueous medium, mixture is or solute mixture is present in the aqueous medium. If you are adding salt, its ionic strength is increasing. Therefore, once the ionic strength is increasing, non-polar compound or non-electrolytic compound is present, that is the undesired or impurity compound, that will be simply eliminated by washing with the organic solvent, because its water is ready to leave from its solution. Therefore, immediately once you are adding the organic solvent, that organic solvent dissolves the non-electrolyte or non-polar compound that gets eliminated from the mixture. Okay. Next, masking agent. What is masking agent? Just we are changing the surface. Changing the surface. Masking agent. A compound, this is also external compound or external substance which is added to the solution mixture, which are interact with interfering material or impurities in a sample solution. After interacting with that sample solution, whatever the impurities present in it, that will be prevent them from getting extracted. This process, this process interactions, this process increases the selectivity of extraction process and reduces the undesirable material from the extraction solvent are getting dissolved in the extracting solvent. Therefore, once you are adding masking agent, it reduces the solubility of the undesirable compounds into the extracting solvents. For example, if we are using cyanides, citrates, fluorides, etc., are acting as a masking agents for metal ions for the extraction. Next, nature of sample. This is also important factor. Nature of sample. Nature of sample. what what sample nature is also important, because we are going to separate the sample after preparation of the we are going to separate the samples into individual compounds. The sample may contain a mixture of compounds in which one of the compound is our desired compound. That is the reason the nature of sample is always affects the extraction process. This is applicable to solid samples, especially. This is applicable to solid samples. The efficiency of extraction is improved if the particle size of the sample is small. Suppose in the sample, if you are providing the sample, the provided sample is in the form of granules, that is well fine crystal structures are generated. Such kind of sample is taking longer time to soluble in the solvent. Right. Once we are grind it in the mortar by using the mortar and pestle, or we are grind it to a powder, that powder mass will be easily soluble in the solvents. Then we can get easily separate them by using the extraction process. That means smaller size material can easily soluble. And the second one, material is porous in nature. Porous means we are called is like a hollow in space. Hollow spaces. Material size may be big, but it is the empty space is more in that particle, that is called porous particles or porous material. Such materials can also easily soluble in the solvents. And the sample is imbibed with the extraction solvents. These kind of solvents are, this kind of solid materials can easily separated by using the extracting solvents. Okay. Thus, the rate of selectivity of solvent extraction process. These are all the factors. These are all the factors, that is the selection of the solvent, pH modifier, salting out agent, or when the salting out agent is affecting as affecting is called as salting out effect, and a masking agent, and a masking agent, and a nature of samples. Nature of sample can also influences the solvent extraction. Based on all these factors, the rate and selectivity of solvent extraction process can be improved by proper choice of extracting solvent. The first factor is the solvent, selection of solvent. Okay. Once you select the proper solvent, you can effectively extract the solute from the solution. Therefore, by proper choice of extracting solvent, we can easily separate the compound. Next, by adjusting the pH of the solution can also effectively we can conduct the extraction process. And next one, by using the modifiers or salting agents, we can also effectively extract the solute from the solution. And using the masking interfering material to eliminate the impurities by which we can get more concentration of the solute into the solvent. By reducing the particle size of a sample, by giving sufficient constant time between the sample and that is the, sorry, by giving the sufficient contact time between the sample and solute, sample and solvent. Suppose if we have, if the some of the solute is taking some time to dissolve in the solvent, if that much of time we are not provided, therefore the desired amount of solute will not transfer into the solute, the solvent. Therefore, we need to provide more time. Once we are providing the more time, the solute should be transferred into the, or it should be dissolved into this solvent, then by which we can get the more amount of solute from the mixture. Then by regulating the temperature, here the temperature is playing important role. Once some in some cases when we are increasing the temperature, the solubility increases. At the same time, impurity compounds also get soluble in the solvent. Therefore, we need to maintain the proper temperature by which we can get the good extraction results. Right? By increasing number of extractions on same sample using only small quantities of extracting solvent each time. Instead of doing extraction by using the bulk solvent at once, we, the same procedure is carried out, the same extraction procedure is carried out by using the minimum amount, a small portions of this solvent, by which we can get the more effective or more amount of solute get separated from the mixture. Okay, this is the these are the factors, and by which these factors are improved, we can get the good results in the extraction. Right? Next, solvent extraction technique can be classified into two categories depending upon the nature of the sample that is to be extracted. Whether solid or liquid, that solvent extraction procedures are two types: liquid-liquid extractions, liquid-liquid extractions, liquid-liquid extractions, and the second type is solid-liquid extractions. Solid liquid extractions. In both the cases, the extraction is carried out. One is the batch extraction method, batch extraction method, and second one is the continuous extraction method, continuous extraction method. Right. Now, first you coming to the liquid-liquid extraction. Liquid-liquid extraction. Uh, in that liquid-liquid extraction. In this liquid-liquid extraction, sample solution containing the material to be extracted, usually here aqueous solutions are used, because that whatever the solid, whatever the liquid liquids compounds are, maybe organic compound, that is can be easily soluble in the is easily soluble in the organic solvent, by which once they are soluble in the organic solvent, we can extract with the aqueous solutions. Or if it is soluble in the aqueous solution, then usually we can use the different kinds of organic solvents. Here the material to be extracted is brought in contact with other solvents like organic. Both solvents are essentially immiscible. This point is already discussed. Why these to be immiscible with each other, immiscible each other. Okay, separation by this method is very simple and rapid and quantitative, because once you are extracted, that should be a quantitative in manner. That means it results the more amount of the compound, more without loss of the compounds from the mixture. Okay, I already told this extraction is carried out in the batch extraction method and a continuous extraction method, from which we come into first batch extraction method. Batch extraction method. Batch extraction method. Yes. What is the batch extraction? This is the most simply widely used method. Just simply take the mixture and extract once with the uh, extract once and collect the extracted solvent at one place. Again, extract the same mixture with a fresh form of the solvent. Again, it collected into the previous one. That means this is called batches. First batch, second batch. On the same mixture, we are adding several times of solute. It will be extracted. All the extractions are combined together. That is placed at one place. Now, what are the important points to be here? You need to remember. In this method, used for extracting solute with a large distribution coefficient in the extracting solvent. Generally, for this extraction, the operator should be used for the method is separating funnel. In the batch extraction of the liquid, we are generally used for the extraction is separating funnel. Right. This is the separating funnel. This is a separating funnel. Look at here. We know that the funnel is, that simple filtration for funnel, simple filtration, we can use the funnel. But here we are using this. This is just a closed vessel. It is having a stopcock and it's a closed lid will be there. In that, first you need to take a mixture, which is a mixture of solute or mixture of compound, which are taken in a suitable solvent to dissolve. After dissolving, the dissolved solution is taken in the separating funnel. Then add organic solvent for extraction. Okay, this is the batch. Once you are adding this solvent to, this is the lighter one, this is the lighter one. Or suppose if the mixture is dissolved in organic solvent, you need to add the aqueous reagent, make it to vigorously shake it and allow it to separate. When it is separated, the densities are should be considerably different. Then only they can get separated. Such kind of care need to be taken. Then only the two solvents should be separated because they are already immiscible. Once we can take the or decant the or remove the solvent from the stop cup and collect it one glass. Again, add the fresh solvent of this higher density that will be extracted the compound present in the above layer. Then again it will reach it to bottom. Again collect it. That means it is the repeated process, one or two or three or four, five, so 5 times we can extract them to get the more compound from the solution. Okay, this is the batch extraction. This batch extraction very common for the separation of the liquid compounds. Okay, next continuous extraction. Next one is the continuous extraction. This continuous extraction method. This method is used for extracting solutes with a small distribution coefficient in the extracting solvent. In this method, continuous flow of immiscible extracting solvent is passed through the sample solution to be extracted. The operator used in the continuous liquid extractions are two types depending upon the density of the extracting solvent. If the density is lighter than the water and the density is heavier than the water. If the density is lighter than the water, whatever the extracting solvent is density lighter than the water. In such case, we are going to use one of the operator setup. This is the setup we are going to use here. What is that setup? It indicates, right. In this extraction, the extracting solvent is lighter than the sample solution. Is placed in a flask A. This is the flask. In this flask, we are going to take the take the solution. Solution is placed in a flask A. The sample solution is placed in the pocket B or body B. This is the body B, and this shape is called body B. In that we are taking the sample solution. Sample solution. Okay. When in this we are inserting a D type of funnel. That the funnel D is inserted. Funnel D is inserted, is kept in the body of B. That is kept in the body of B. And condenser C is attached to the, this is the condenser C. This condenser C is attached to the extracting solvent in flask A. condenser C is attached. Then the extracted solvent present in this A is heated by using some flame or some heat source. That is heat source. By using a heat source, we can heat it. When we are heating, a vapor will be generated. That vapor will go through this body B, and this vapor enter into the condenser. Once this condenser um, this vapor is entered into the condenser, that will be condensed to liquid. That liquid is fall down into the funnel. Then once this fall down in the funnel, that is in contact with the solution or sample solution present in the body B, then whatever the compound solute is present in this body B will be transferred into the solution. Once it reaches to the maximum position or higher position of the funnel, then the solvent again will move into the flask A. Therefore, it is the continuous process until we are getting the more amount of solute from the sample mixtures or sample solution. Okay, this is the one method. When we are using it is lighter than the water sample. Now, next, heavier than the, or more denser, heavier than the water sample or water solvent. In such case, we are going to use a special setup, that is, this is the setup we are going to use. In this setup, what's happening? The extracting solvent heavier than the sample solution is placed in a flask A. The extracting solvent heavier than the sample solution is placed in A. In this flask, we are going to add the solvent, which is used for the extracting solvent, right? Then the sample solution is placed in the body B to half capacity. To half capacity, we are filling the sample solution. And the extracting solvent in flask A is heated. The vapors are extracting solvent pass to the condenser through the side M. Through this side M, the vapors will be passed through this condenser. Once this condenser reaches these vapors are reaches to the condenser, that will be condensed and fall back to the body B. That is in contact with the sample solution. Once the sample solution in contact with the solvent, that will be dissolves the compound or solute, then it moving down to the previous solution.